All right. Well, look, it's a pleasure to join you. I thought I don't know what your timing is. Martha and Lisa, you had said 20 minutes and a few minutes for questions. I'd like to try to keep to that. Let me start by just saying that it's a pleasure to be with you, even though we have some technical difficulties. I'm in a shared office space now. I'm traveling, so apologies for the background, for whatever background noise there may be. By way of introducing myself, I won't go through this, but I wanted to highlight that this website, jedfahey.com, on this website I have hopefully all of my publications, and I'll be referring to some of them through this talk. Feel free to go and grab them. They're in PDF form. I spent most of the last 30 years at Johns Hopkins. I've now retired, and I'm consulting for a number of small companies. Why am I here? I'm here really because of Albert Wright. I'm assuming, based on the mentioned supplying exogenous myrosinase. We know that doubles at least the bioavailability of sulforaphane. We've done a number of clinical trials on it, others have too. But again, there is great person-to-person variability in both conversion and in bioavailability. The sulforaphane has a broad research landscape at this point. Work started with my mentor, who brought me to Hopkins in 1992, and had just published on sulforaphane and some of its cancer preventive potency. There are now 500 or so papers a year on sulforaphane. Much more importantly for this conversation, there are many, many clinical studies, over 125 of them, that address sulforaphane outcomes in both healthy individuals and individuals with various conditions. There are many, many pathways, we don't have nearly enough time to talk about each of them, through which sulforaphane has been shown to impact brain health and cognition. I'll mention a couple of them in a little bit more detail as we go through, but NRF2 pathway, detoxification, mitochondrial health and function, very important, neuroinflammation, various factors involved in gut-brain axis interactions, and then mechanisms like neurogenesis, synaptic plasticity, heat shock response, apoptosis, autophagy, and epigenetic effects. I list these, talked about them in a review. All of them have either substantial or at least some evidence in vitro and in preclinical trials, and some of them, as I say, in clinical studies. We'll talk about that in a second. The only thing I want to say here is just to let you know or remind you or tell you that sulforaphane does cross the blood-brain barrier readily, and it also supports blood-brain barrier functionality. I'd like to go through this NRF2 pathway in just a little bit of detail because although it's an extremely important pathway, a lot of people don't know where. So sulforaphane activates this NRF2 pathway in the following way. If you envision this whole slide as a cell, there's a chaperone, or actually a dimerized chaperone protein in the cytoplasm, a tether protein called KEAP1. It maintains NRF2 in the cytoplasm. When sulforaphane or other NRF2 activators enter the cell, which they do readily, they bind to two particular reactive cysteine residues on KEAP1. They alter the conformation of that KEAP1, and NRF2 migrates to the nucleus, where it acts as a nuclear transcription factor and governs the coordinate regulation of a whole suite of so-called phase 2 enzymes. Those enzymes responsible for detoxification and antioxidant activity. These induced or upregulated enzymes represent about 2 to 5% of the total cellular protein that's being transcribed, upwards of 500 proteins. One of the things I'd love you to remember from this or take home from this is that, remember, enzymes stick around themselves for a while once they're made. So when we speak of sulforaphane as an indirect antioxidant, which we do, what we're saying is that it creates or enhances or upregulates or boosts antioxidant proteins or enzymes. Sulforaphane in itself is not an antioxidant. You can tell by the chemistry of it. But it upregulates the protective and antioxidant enzymes. And others, Antonio Quadrado and others in a fairly recent review, God, time's flying, it's 6 years old now, but listed a whole slew of representative genes that are transcribed by NRF2 when NRF2 is upregulated. And I've just summarized the or condensed the half-lives of them here. So again, just to remind you, half-lives range from certainly hours on this one, the second one, air pollutants. We've shown, I think unequivocally, you may argue, but we've shown that in people, the conjugates, the detoxification products of, for example, some environmental smoke, benzene and acrolein, can be seen coming out in greater numbers after administration of sulforaphane. I mentioned, I see Martha's face coming into the screen, probably telling me it's time's about up, but so I mentioned mitochondrial function. There are many modes in which sulforaphane affects mitochondrial function have been demonstrated at this point. I'd like to just very briefly point out this list in which I've tried to evaluate very roughly the quality of evidence that goes along with the effects of sulforaphane on some very specific brain disorders. Mood and psychiatric conditions such as autism, schizophrenia, diabetes-related cognitive decline. So if we just take these top three, for example, the evidence on autism is very strong. We've done a lot of work on it. I'll share one set of studies we did with you, and there are now 9 or so published clinical studies on sulforaphane and autism. Schizophrenia, we've also done a number of them. Evidence isn't quite as strong, but there are good clinical studies now on it. Diabetes, I call it moderate. There is good evidence. I've been part of these clinical trials that is involved in moderating the influence of diabetes and prediabetes. Nobody's yet made the connection between diabetes, between sulforaphane and the well-known diabetes-related cognitive decline. Going down to Alzheimer's, Parkinson's, and so on, there's a lot of evidence, not much clinical evidence. And of course, Albert Wright's evidence on Parkinson's disease is something that I'd like to bring up at the very end. Martha, nod or shake your head. Do I have time?
No, you can go ahead.
Okay, a couple of things on our autism work, since we've done quite a bit on it. One of the things we did, this was published in 2014, was with young men, 13 to 31 years old, as I remember. It's been a while now. We gave them either a sulforaphane beverage made from broccoli sprouts, or a placebo, and we monitored based on standard behavioral scoring mechanisms, the average behavioral checklist and the social responsiveness scale and others. We monitored sort of classic autistic related behaviors, irritability, lethargy, repetitive movements, etc. I'm not a psychiatrist, and I've forgotten which one of these. One of these is a caregiver scale, and the other is scored by the attending physician and the neurologist in the case of this study. This was a collaboration with a group between our group at Hopkins and a group at Harvard at the time. So there was a substantial improvement after 4 weeks on sulforaphane beverage, 10 weeks, and maintained at 18 weeks. And then, I think this should change then. No, sorry. This slide got left out here, but then there was a 4-week washout period from 18 to 22 weeks. And those on treatment came back to approximately placebo levels in both these cases, and looking at the subscales of autism. We then, and this paper wasn't so widely read, but I think it's actually the more fascinating of the two. Then we actually took those who had improved on sulforaphane and followed them up for another 3 years, during which time they were not on our Johns Hopkins produced certified known quantity of sulforaphane. But these parents and caregivers had come to us and said, "Doc, what do we give our kids?" They folks in this study reported positive symptom response with really a quite small dose, equivalent to about 25 to 40 micromoles of sulforaphane, equivalent to the amount you'd find in a half a gram of seeds. And this is a very much lower level than for comparable non-Parkinson studies. We are fascinated by that. If any of you are familiar with the way clinical studies typically are done and get funded, what many times happens is there'll be a positive study, and then the next study that someone does, they'll dose at that level or higher. And of course, dose escalation is quite popular. Dose de-escalation, not so much. People don't want to get their hard to get, even harder to get these days, grants, and then realize, and then use a lower dose and find out that it wasn't efficacious. I give Albert huge credit for exploring the low end of the scale, and we don't know enough now. We still don't know enough about what the proper dose is. And as you probably know, then he reported that some people actually have reduced efficacy if they use viruses, and some of them increased to multiple doses a week. So yeah, let's move to questions, because I think we're taking enough time. I realize this is a precious few days that you have in this resort. I wish I were there, but I'm going to close this screen and hope this has incited some dialogue or a few questions. Thank you.
There was this